bucka. Haha. You know the deal. This is me.
The next thing we're going to look at in our number sense unit is adding and subtracting large numbers. So these are numbers that are usually at least in the hundreds. And when you're adding or subtracting large numbers, there's two questions that you want to ask yourself. Do you need to have the exact answer, or do you need an estimate or an approximate answer? What we're going to do is we're going to first take a look at if we need an exact answer, the process that we would use in order to add or subtract large numbers, and then we'll talk about if you only need to have an approximate answer. So if we're having to add or subtract large numbers and we need an exact answer, we use what's called an algorithm. Now, you're probably going to ask yourself, what is that? What does an algorithm mean? Well, an algorithm is a word that mathematicians use to describe a process or a step-by-step procedure that works every time in order to solve problems. So first what we're going to do is we're going to take a look at the algorithm. Now, one of the problems with an algorithm is it doesn't really show any understanding necessarily of why you're doing what you're doing. So first we're going to look at what the algorithm is to add and subtract large numbers, and then I'm going to talk about why the algorithm works. And again, an algorithm is a step-by-step procedure for calculations, so essentially a set of rules that works every time. And that's what we're going to look at first for adding and subtracting. And we're going to start with adding very large numbers. So with this first example, we have a question where over 2 days the attendance at a hockey game was 8,135 the first day and 9,288 on the second day. And the question is, what was the total attendance for both days? So hopefully you recognize here that in order to answer this question, we have to take the attendance for each day and add those two numbers together. Now, there are a few ways to answer this question. Like most questions in math, there are a few ways to approach it. And the algorithm that I'm going to show you here is one way to approach answering adding two large numbers like this. So what we're going to do now is go step by step through the algorithm, the one way that I'm going to show you how to approach this type of question. So the first step in our algorithm is to write the numbers on top of each other. Another way to say that is to stack the numbers, and we want to line up the place values. So the place values are essentially in a column, and I'll show you what I mean by that with this example. So here we've taken these two numbers and stacked them, written them on top of each other, lining up the place values. So here in this column we have the ones place, then the tens, then the hundreds, then the thousands. Now, we don't have any bigger places here, but if we did have bigger places, it would continue on. And it's possible that one of the numbers will have more places than the other, which is okay, and we'll look at an example like that, but you still line up the place values on top of each other. Now, it's important to note here that with addition, it doesn't matter with addition what order you add things in. So it doesn't really matter which number goes on top. Typically, we put the larger number on top, but it doesn't really matter because 8,135 plus 9,228 is the same as 9,228 plus 8,135. So in this case, we actually put the smaller number on top, but it doesn't matter with addition. With addition, either number can go on top. So once you've lined up the place values and stacked the numbers, you're going to start with the place value furthest to the right, and in this case, that's the ones. It's possible that the place value furthest to the right could be a decimal, a value smaller than the ones. But here, furthest to the right, we've got the ones. So we start with that place and we add those digits. So in other words, we're only adding the digits in this place value, 5 plus 8. Now when we add 5 plus 8, we get 13. We want to write the answer to this in the ones place, but we know that we can only have one digit in any place. So if you add those two digits together and you get a value that has more than one digit, you do what's called carry one of the values. So once again, here we want to start by adding 5 plus 8. We know the answer is 13. We can't write two digits in any one place. We can only write one of those digits here. So here's where we're looking at this possible step here. If the answer has more than one digit, we write the digit furthest to the right. And in 13, the digit furthest to the right is a 3. So that's our digit furthest to the right, and carry the other digit above the next place. Now the next place is our tens place, and in 13 the other digit is a 1. So we carry or write the 1 above what's in the tens place. Now again, I am not going to explain right now why this works. We're just going to go through the algorithm and then we're going to talk about why it works. Now that we've carried that 1, we add all of the digits in the next place values. So essentially now we're just continuing with this second step. We're adding the digits. We're working our way left. We started with 5 plus 8. We got 13. We can't write two digits in one place, so we wrote the digit furthest to the right, the 3, and carried the 1 above the next place value, which is the tens. Now we're going to add the tens. 1 plus 3 plus 8 is 12. Once again, we can't write two digits in any one place, so we write the digit furthest to the right, which is the 2 in 12, and carry the 1. Now we have 1 plus 2 in the hundreds place. Well, that's only 4. We can write that one digit in the answer there. There's nothing here to carry. Now we have 8 plus 9. 8 plus 9 is 17. Now, normally we would just write the 7 and carry the 1, but because we're at the end here, there's nowhere left to carry that digit, so we can write the final answer of 17. So now we've used the algorithm to add these two very large numbers, and we found that 8,135 plus 9,288 is 17,423. So that's how many people attended both hockey games. So here's another example where we've got a word problem where the town of Fort William has a population of 48,175, and the town of Port Arthur has a population of 127,312. And the question is, what is the population of both towns? So hopefully you recognize in order to answer that question, we have to add these two values together, 48,175 plus 127,312. So we're going to go right to the algorithm here, and I'm going to start by writing the numbers on top of each other, stacking them up and lining up the place values. And in this case, I am going to write the larger number on top. Again, it doesn't really matter with addition which order you do it in, but typically we put the bigger number on top, and I am going to do that here when I stack them. So now once again, our place furthest to the right is the ones place because we don't have a decimal involved in this question. So we start with that place value furthest to the right and start adding the digits. 2 plus 5 is 7. There is only a single digit in that answer, so there's nothing to carry to the next place. We continue from the right, working our way left. 1 plus 7 is 8. Once again, nothing to carry. 3 plus 1 is 4. Now 7 plus 8 is 15, so we have to write the digit furthest to the right in 15, which is a 5, and carry the 1 in 15 to the next place value, the 10,000ths place value. 1 plus 2 plus 4 is 7. There's nothing to carry, but there is still one place value left here, the 100,000ths. Now the 100,000ths doesn't have anything to add to in the other value, So we could put a 0 there if we wanted to. That doesn't change that value at all. And 1 plus 0 is 0. You don't necessarily have to write that 0 if you don't want to, but sometimes it helps people see the place values lined up if they have a digit in every place value that's there. So once again, we've worked our way through the algorithm, starting with the first place value, the place value furthest to the right, adding those digits up one at a time. When we had an answer that was more than one digit, like here, we had 15, we wrote the digit furthest to the right, which was the 5 in 15, and carried the 1 above the next place value. Continuing our way left until we ended up with no more values to add, and we found that the combined population of these two towns is 175,487. So in the next example, we're going to look at subtraction, and so we're going to talk about the algorithm for subtracting. So this is now going to be a slightly different algorithm, so I suggest you copy this down again, but now it's for subtracting. Now, fortunately, the first two steps for subtracting are the same as for adding it. And again, there are several ways that you could approach answering a question like this, and what I'm going to show you here is one way to do that. And one way we can approach answering this question is using this algorithm. So we start by writing the numbers on top of each other, lining up the place values. Now, unlike addition, with subtraction, it does matter what order you subtract in. And it's not necessarily that the biggest number will always go on top. For the examples that we're going to look at, the biggest number will always go on top. When you get to grade 7 and beyond, you start talking about values that are smaller than 0. So it's possible that you can subtract a bigger number from a smaller number. But since this is a grade 6 video, we're only going to be looking at examples where we're subtracting a smaller number from a bigger number. So in these examples, the bigger number will always go on top, but that's not necessarily always the case. And do remember, it is important what order you subtract in. But hopefully after you've read this example here, you realize you have to take 8,137 and subtract $375 from it, because he started with $8,137 in his bank and he took out $375 essentially by paying that bill. So we're going to start by writing the numbers on top of each other, stacking them, and lining up the place values. And just like with adding, we start with the place value furthest to the right. In this case, it's the ones, because we don't have a decimal here. We don't have any cents written in this bank balance, just whole dollars. So the smallest place value we have is the ones place. So we start with that and we subtract 7 minus 5, which is 2. And we continue working our way left. And here the question is 3 minus 7. Now, it is possible to subtract 3 minus 7. However, we end up with what's called a negative number, something you're going to learn about in grade 7. And in this case, the answer to this question cannot be negative. So in this case, we cannot subtract 3 minus 7 because we can't end up with a negative number. So we have to do something about this 3. We have to somehow be able to subtract what's here from what's underneath. In order to do that, we have to do what's called borrow from the next place value over. We have to borrow 1 from that and essentially give that 1 from that place value to the place value that we're subtracting. So once again, if the digit below is larger than the one above, which is the case here the digit below is 7 and the digit above is 3, we have to borrow 1 from the next place to the left. So the next place to the left is our hundreds place. We're going to borrow 1 from that. If I take 1 from 1, we get 0 there. And what we're going to do is we're going to take that 1 and give it to our digit here. And by giving it to that digit, to that 3, what we've essentially made there is 13. It's kind of hard for me to squeeze that 1 in there, so usually I write it on a little angle above, but that's essentially what that means there. That's 13. So now instead of 3 minus 7, we have 13 minus 7. And 13 minus 7 is 6. Now once again, the digit above is smaller than the digit below, or the digit below is larger than the digit above. We have 0 minus 3. We are not able to do that here, 0 minus 3, so we have to borrow 1 from the next place over. Borrowing 1 from an 8 makes it a 7, and we give that 1 over here. So now instead of a 0, we have a 10, and 10 minus 3 is 7. And now we have our last place value, which is our thousands place. We don't have a digit in the thousands place down here. Again, we could put a 0 if we want to. It doesn't change that value at all. 375 is still read as 375. And 7 minus 0 is 7. So the answer to this question is Tony has $7,762 left in his bank account. So looking at our next example, we've got a dance going on where at 9 p.m. there were 562 people at the dance, and then at 10 p.m. there were 812 people at the dance. And assuming people can't just come and go, the dance is just continuously filling up, the question is, well, how many people came in between 9 and 10 p.m.? So hopefully you recognize, well, in order to calculate that, we have to take 812 and subtract 562. Again, it just so happens we're starting with the biggest number and writing that on top here. And that's what we're going to do. We're going to go through our algorithm, and we're going to start by stacking the numbers on top of each other and lining up the place values. And now starting with the place furthest to the right, which is the ones, once again, we're going to just start subtracting. 2 minus 2 is 0. Next case, we have 1 minus 6, so the digit below is larger than the digit above. We have to borrow 1 from the next place value over. Borrowing 1 from the 8 makes it a 7, and we give that 1 to this place value, turning that 1 into an 11. 11 minus 6 is 5, and 7 minus 5 is 2. So the answer to this question is 250 people came into the dance between 9 p.m. and 10 p.m. So the next thing we're going to take a look at with subtracting large numbers is what happens if, when we go to borrow from the next biggest place, well, what happens if there's a 0 in that place? So just as is the case in this example, so if we take a look at our smallest place value here, our furthest place to the left is the ones place, and we have 3 minus 5. And we're not able to subtract 3 minus 5 here because 5 is larger than 3. So we're looking to the next place to the right, and we want to borrow from that place. But we have a 0 there, and we're not able to borrow from that 0. So what we have to do is continue working our way left to the bigger place values until we are able to borrow from one of those values. And if we look at the next value to the left, again, we have a 0. We're not able to borrow from that 0, so we continue working our way left. And then in the next place, in the thousands place there, we have a 2. Well, we can borrow from that 2, and we're going to borrow a 1 from that 2. And borrowing a 1 from that 2 makes it a 1. We give that 1 that we borrowed to the 0, making it a 10. Now remember, we needed to borrow from the next place over to the right. We needed to borrow from this 0 here. So again, we have to borrow from 10. Borrowing a 1 from 10 makes it 9. And that gives us a 10 in this place, in the tens place now. And now finally we can borrow 1 from that, making it a 9. And we can give that 1 to the 3, making it a 13. And now finally we're able to subtract 13 minus 5, since we borrowed and we had to go all the way to the thousands place to borrow 1 from that, giving that 0 the 1 and turning it into 10. Borrowing 1 from that, we made that 10 into a 9, gave it to this 0, making that 0 a 10. Borrowed 1 from that, made it a 9, gave that 1 to the 3, and made it a 13. 13 minus 5 is 8, 9 minus 7 is 2, and 9 minus 8 is 1. So 2003 minus 1875 is 128. So when you get into a situation where you go to borrow from the place to the left and there's a 0 there, you have to continue working your way to the left until you get to a place that you can borrow from, and you make that 0 into a 10. So now that we've taken a look at how to approach adding or subtracting very large numbers using an algorithm when we need an exact answer, we're going to take a look at an example where we don't necessarily have to have an exact answer. So often times you're dealing with a situation where you don't need to know the exact value. You can find an estimate for the information given. And when you need an estimate, usually the way we approach that is we round the numbers to make adding or subtracting these large numbers easier. And it's usually to the largest place value in whatever digits you're dealing with. Sometimes, depending on the information that you're looking for, it might make sense to round to a particular place value, or you might have a question where it tells you to round to a particular place value. But unless it specifies that, you can assume that it's okay to round to the biggest place value. And then you just add or subtract those rounded values. So let's take a look at an example here where we've got a situation where we have the population of muskellunge, which is a type of fish in Lake Ontario. These numbers are all made up, but suppose in 1968 the population was 19,838. And then in 2014, the population was 8,132. And the question is, approximately how many more muskellunge were there in 1968 compared to 2014? The important word here is approximately. And approximately means you only need an estimate. You don't need to know the exact number of fish here that there were. So since we need an estimate, we're going to take each one of these values and start by rounding them to the largest place value that they have. So here are two values that we're dealing with here, and I'm not going to go through a lesson on how to round. There is a video on rounding numbers, but the biggest place value that we have here, the place value furthest to the left, is the 10,000s. So if we round that number, 19,838, to the nearest 10,000, we get 20,000. Looking at our next view that we have there, the biggest place that we have is the thousands place. And if we round that number to the nearest 1,000, it rounds down to 8,000. And hopefully you recognize here, in order to figure out how much bigger that first number is compared to the second number, what we have to do here is we have to subtract these values. Well, the nice thing here is if we follow the algorithm that we just talked about, the first few places here, all we have is zeros, and 0 minus 0 is 0. So that's the nice thing about estimating, is that when you don't need an exact value and you've rounded, you tend to start with a bunch of zeros that you either have to add or subtract, which is quite simple to do. Now here is a case where the number on the top is smaller than the number on the bottom, so we have to borrow a 1 from the next biggest place value and give that 1 to that place, turning that 0 into a 10. 10 minus 8 is 2. And then the last place value we have here is the 10,000s in this number. This number down here doesn't have anything in the 10,000s, so we can assume that's a 0 in the 10,000s. 1 minus 0 is 1. So the answer is that there's approximately 12,000 more fish in 1968 than there were in 2014. So now that we've taken a look at the actual algorithm for how to add and subtract large numbers, or one way to add and subtract large numbers, it's important to understand why that algorithm works. So for the rest of the video, I'm just going to talk about why this algorithm, why it works, why you're able to add and subtract large numbers in this way. You know, it's important to understand where these rules come from and why they work mathematically in order to really understand them. So I'm just going to spend a few minutes to talk about why you're able to add and subtract large numbers in this way. So if we take a look at this example here, we've got two values with values up to the hundreds, and they're not huge numbers, but they're pretty big, and we might want to add them by stacking in the way, and then adding in the way that we've talked about in this video. But I'm going to explore why the algorithm works, and what we're going to do with each number here is look at the value of each digit and write each number in what's called expanded form. So I'm going to start with 238. I'm going to start with the biggest place value, which is the hundreds. And in the hundreds, we have a 2. Now, sometimes you'll face these questions where you're asked for the value of an underlined digit. Well, what that means here is well, we've got a 2 in the hundreds place. So essentially what that's asking is, what is the value of 2 hundreds? And the value of 2 hundreds is 200. Working our way to the right in this number, getting to the smaller place value, the next biggest place value we have is the tens. The digit we have in the tens place is a 3. So the value of that digit is 3 tens. 3 tens is 30. And finally, the last place value we have working our way to the right, the smallest place value that we have here is the ones. We have an 8 in the ones place, and the value of that 8, well, the value of 8 ones is just 8. In order to write a number in what's called expanded form, what that means is we take the value of each of the digits in the number, which we've done here, and we turn this number into essentially an addition question, where we take the value of each digit and we show that if we added those values together, it would equal this number. So 238 can be written as 200 plus 30 plus 8. That's called expanded form. So similarly, if we take our second number here, 895, and write that in expanded form, we take the value of each digit there and write it as an addition question. It would look like that. 800 plus 90 plus 5, which would be the same as 895. So again, this is called writing numbers in expanded form. Well, if we go back and take a look at the original question, we know here we're adding these two numbers. So we're taking what's on top and adding it to what's on the bottom. And so when we look at this in terms of each place value, well, our algorithm starts with the smallest place value. So we're adding 8 plus 5. Now the thing here is 8 plus 5 is 13. I only want to know how many ones I have in this place, not how many tens, but 13 is 3 ones and 1 10. Well, I have to include that 10 in the tens place, and that's the part that I'm carrying. Now in our algorithm, we would just add 8 plus 5, that would be 13, and we would only carry the digit of 1 above the next place value. But we can see where that comes from here. We're really carrying a 10 to that place value. And then again, we've got a situation here where we're going to add what's in the tens. 10 plus 30 plus 90 is 130. I don't want to know how many hundreds I have, though. I only want to know how many tens I have. Well, 130 includes 3 tens, the 30, but I have to take that 100 to the hundreds place, because I'm only writing the value that I have for tens here. And in 130, well, we have 3 tens, the 30. We have to take the 100 into our next place value. Again, if we look back at our original question, in our next place value here in the tens, we would add the 1 plus the 3 plus the 9, which would give us 13. But again, we would only write the digit furthest to the right and carry that 1. And that's what we're doing here. We're taking our 130 and only taking what's in the tens value, which is 30, and then we have 100 to put in the hundreds place. Finally, we have 100 plus 200 plus 800, which is 1,100. Now, if I were going to continue writing this in expanded form, I would have to write 100 in the hundreds place, but then I have 1,000 that I could carry, but I don't have to, because we don't have any more numbers, any more places here to add. So in expanded form, we've got 1,100, 3 tens, which is 30, and 3 ones, which is 3. Going back to our original question here, we carried that 1, so we have to add 1 plus 2 plus 8, which is 11. Now that there are no more places left, we don't need to carry. We can just write the answer of 11. If we take the answer that we got here in expanded form and put that back into standard form, we have 1,100, 3 tens, and 3 ones. So you can see we end up with the same answer. So once again, this is really why the algorithm works. We're taking the value of each of the digits here and adding them together. If we end up with more than one digit, we have to carry that over to the next place. Right? We have to take that over to the next place value. Well, to explore why the algorithm also works for subtraction, we're going to explore it in a similar way. We're going to start by writing each one of these numbers in expanded form. And what we're going to look at here is subtracting each one of the places here. Now, in this case, the top number is subtracting the entire bottom number. So I'm going to put subtraction, but I'm also going to put this bottom number in brackets so that we know when we're starting with the ones, we're taking 7 and we're subtracting 8. And then similarly, we have 30 and we're subtracting 50. So that's why I put those brackets there. So here, if we start to look at this, well, we want to subtract 7 minus 8. I'm not able to subtract 7 minus 8 in this case because I don't want to end up with a value, or I can't end up with a value that's less than 0, because 738 is bigger than 158. So we know our answer has to be greater than 0. So since I am not able to subtract 7 minus 8, I essentially have to borrow a 10 from this place value. So I'm going to borrow 10 from that 30, which means I'm going to make a 20. And I'm going to add that 10 to the 7, making it 17. So now we're able to subtract 17 minus 8, and we get 9. Similarly, when we go to our next place value, we have 20 minus 50. I can't subtract 20 minus 50 here, so we have to borrow 100 from the 700. I'm going to take 100 away from 700, making it 600, and add it to our 20, making it 120. 120 minus 50 is 70. And now our biggest place value, we have 600 minus 100, which is 500. And putting that in expanded form, we're just writing that as an addition question. Going back to our original question here, we start with 7 minus 8. We're not able to do that here, so we have to borrow from the next biggest place value, taking 1 away from it, and giving that 1 to the 7. 17 minus 8 is 9. Again, we're not able to subtract 2 minus 5 in this case, so we have to borrow from the next biggest place value, take 1 away from that, and give that 1 here, turning that 2 into a 12. 12 minus 5 is 7. And finally, we have 6 minus 1, which is 5. Now, if we take our expanded form answer here and write it back in standard form, 5 100ths, 7 10s, and 9 1s gives us 579, which is the same answer that we got using our algorithm. So to finish off our lesson on adding and subtracting large numbers, I'm going to answer a few questions here. So in the first question, we got Acme Roofing Company, and they're going to charge $3,145 for materials to replace a roof and $5,958 for labor. They guarantee the roof for 10 years. The first question is, what is the total cost? So for both labor and materials, how much does it cost in total if you're going to get Acme to replace your roof? The second question, or the second part of this question here, says that another company charges $12,728 for both labor and materials. They guarantee the roof for 20 years, though, and the question is, how much more does this company charge compared to Acme? Question number 2, we've got the population of Toronto in 1972. These numbers are all made up, but just assuming the population was around 837,142, and in 2013 the population was 3,172,491. The first part of this question is, how many more people are there in 2013 compared to 1972? And the question here says approximately. So that's an important word here. So in this case, you only need an estimate for how many more people there are in 2013 compared to 1972. For part B, it's asking for an exact answer. How many years, exactly how many years have gone by for the population to grow this much? So in other words, how many years are there from 1972 to 2013? If you're able to answer those questions, congratulations, you now have a firm understanding of adding and subtracting large numbers.